Hi guys, this is Elijah. If you haven't met me before, I am one of the TAs for your MATLAB course this semester. Um, I'm not sure if you can see me since no one's in the office hours right now. Hopefully you can. I should be sharing my screen. Let me make sure I'm sharing the correct screen. Can you share? Yep, desktop one, share. Okay. It's working. So yeah, I wasn't able to make it at some of your guys' first lessons. I tend to only come to the last half of class to allow enough time for office hours. So I wasn't exactly sure everything that has been covered. Um, so I just kind of wanted to go over some best practices and some formatting stuff that we have been doing in the course with the previous professor for, I want to say this is my fourth semester TAing, just kind of to make things flow a little better for grading and checking out, and just kind of help you whenever you possibly use some of the stuff at your workplace. So I have a little outline of what we're going over today that I will show real quick. Just kind of, this is going to be like a short little video, but just to run through, we're going to go over what it's like starting a project, just to kind of make sure you're getting set up and not having to worry about presentation or anything as you're trying to actually just solve the problems. The other thing is formatting, again, kind of the same thing, but as you're working on the project, things to keep in mind. Debugging. So I'll just kind of give some tips about that, because obviously that's a big part of programming, is not arriving at the answer and trying to get to that answer. And then publishing submission, which some of the stuff, like I said, has not been covered in class. So this is kind of like the stuff that isn't really content towards MATLAB, as far as, like I said, best practices for coding in MATLAB. So without further ado, let's get started. So I'll start off by showing you what I'll typically do when I start a project if I was in this class, which I did take the class just like you guys. So yeah, I would go to home. So you have the toolbar and you have new script, new live script. You can do it from here, and you have an option for some things. We're not going to worry about that stuff right now. But what is the most readable thing? And you can see, like, I have a purple background and different colors and stuff. That's just my personal preference. Like, don't worry about that. It's pretty much the same thing as what you guys, it's also 2018 instead of 2020, but everything's pretty much the same. So we want to do new script, and that's going to, when we go to save that, so let's see, editor. So you would go over to editor, which is also gives some of the same like redundant buttons, but yeah, you go save as, and so we'll just do, I'm in one of the folders from whenever I was in the class, so we'll just do lesson demo. And you can see down here, it's a .m file, not a live. Live is like something interesting for instructors. It kind of lets you like go on the fly, not really practical for submissions or readability for an assignment. So we'll go with .m, go ahead and save that. So that's done. You want to make sure you do that at the beginning, and then just get in the habit of clicking save. I know whenever you debug by pressing the play button, it's supposed to save automatically, but save often. That's like a little mantra. But yeah, so if we go and look, so what I would typically do when I first start off is I would do some commenting. I would just say my name and maybe the date and what else I put? and then like lesson 2. We're not gonna really care if it looks pretty. And then I would start my file with some really basic things that help when you're trying to debug and you want to start fresh. And you can see over here in our workspace, we don't have anything. So that's fine. That's what we want to see when we start a new project. No variables, command window's also clean. But if it wasn't and there was stuff, so for example, if we had something down here where like a = 2, now we have a variable. Now what if we try to work with a, it already has the value assigned to it. So what we would do is we would typically put this at the beginning of a script, which is CLC, clear all, and close all. There's other things like hidden and other stuff like that, but I don't need to worry about that. So what this line does is CLC clears the screen, or the command window, clear command. I think that's what it stands for. Clear all clears any of the variables in the workspace. Then close all if we had like graphs and things, which I think we do this week or in the next lesson for lesson 3 or 4, it would close all those. So we're going to go ahead and just run this. You can see it does exactly that. So next up, so this is where I would put, maybe problem 1 next. So kind of like I mentioned already, the workspace, command window, and the editor, and then of course your current folder area, navigating through that. You want it to kind of look the way I have it. Like obviously if you have a preference, but I think this is like the easiest to see what you're working with over here. And if you want to run some quick, like I was showing you, things like that, then you can just kind of evaluate one line and then see what's going on, if there's a problem, whatever. So yeah, if I was doing that, I would make sure I have this docked in an area that I can see it, and same for these. Just these are like the 3 necessities. And if you need to figure out how to dock or undock something, just look it up online. I'm not trying to spend too much time on that. So yeah, I'll clear everything out, and then things that you want to appear in your current folder that you'll see should see like .m files, the ones that you're running, and a repository that you're working in, or like the folder that you're working in. And if it doesn't run, it'll usually say add to path. So you would just this is grayed out, so MATLAB wouldn't be able to go in there unless I add it to the path. That's what that means, if that ever becomes a problem. And I know I'm talking fast, but you guys can watch this at whatever speed you guys want, so that's the good thing about it. Yeah, and then the other thing is what's in the HTML file. We'll talk about that in a second, but that's the published final product, the PDF. And yeah, we'll talk about that in a second. So back to the editor, whenever we're working with that, we want to section each problem. I know I spoke to some people about this, but essentially what this does is we have a large file that has a bunch of different problems. You can isolate them to just different problems. This ends up sectioning in the PDF, and it looks real nice and pretty. But basically, if I can successfully accomplish problem 2, but for whatever reason I go back and problem 1 wasn't working, I don't need to run the whole script and just run the section. So I would hit that, and it would do what it needs to do. So for example, is equal to 2, and so run that. You can see that does it there, that does it there, and if I hit all, it's going to clear everything out and then run through everything. So you end up getting the same kind of view. So that's that. The other thing I wanted to talk about, let's move my little bar, is, yeah, so we talked about heading, area, sectioning, as far as formatting goes. Oh, variable names. So for readability and to not clog up what your report will look like in the PDF file, anything that doesn't have to do with the final answer, you need to throw a semicolon on that. Your guys are going to work with arrays or vectors, whatever you guys want to call them, and they're going to hold a lot of values, and if you don't have a semicolon, it's going to take a long time to display all those in here. Like, you're just going to watch it just like go through, and it's going to fill up your command window. We don't need that unless it's asked for specifically. So an example of what I'm talking about for what we'd want is we would say, okay, A equals 2, and the problem says have B equal to 3. Change this to C real quick. And C is equal to A plus B, and that's the answer. So what I would want to do is I want to display the answer, so I want that to run through the command window. But the problem is with C equal to A plus B, it's going to say C equals and then the answer to that, which should be 5. That isn't technically very readable because if I'm grading, I'm trying to get through everybody's stuff. I don't want to sit and be like, okay, was C something that was asked for? What is this? So some of the things that I would recommend doing is maybe naming it the problem. If it's like a very basic problem and there's not really much description about it, I would say prob 1a is equal to that. And then whenever we run this, it's going to say prob 1a's answer is that, because maybe there's prob 1b's answer, which is a minus b. And so that just lets us quickly be able to see that. And again, you'll see what that looks like when I show you the PDF of basically my lesson 2 that was assigned to me whenever I was in the class. Excuse me. So that's that. Another thing is if it specifically asks for what is the radius of blah, blah, blah. And if it asks for it, you could just say like rad is equal to, just like short. You could just, pretend that this is like the radius of the circle. You could just say radius is equal to A, something like that, or maybe they give the diameter and you need to find that. And so you would give it a very specific. If it asks for a couple of things, like what's the area of a circle with radius A, then you would say area equals. And then maybe it asks for a couple different, like what's the area if A is the radius, what's the area if B is the radius? And you would just say area 1 is equal to that, area 2 is equal to that. That just, like I said, makes it very readable and easy to follow, and something that's not really that important in this class is like just notation. So some people will section words with, like, for example, this doesn't really mean anything, but that's one way to name a variable. Again, I don't know how much coding experience people have usually at this point in the class. Like, some people have never, so I'm just kind of trying to run through simple stuff. So field scores, this is the lowercase and then this uppercase for that. Really depends what kind of language you're in, MATLAB or Python or something. There's a bunch different. There's camel notation. There's the underscore style, which is like that. And then there's just like a bunch of different rules, but I'm just trying to show you guys like readability. That's the kind of stuff we're looking for, and what most people will be looking for. Then so yeah, readability of answers. Commenting. So commenting super important. You can't work on a team, whether you're mechanical, trying to get a system, machines to do something, wherever. You can't collab with other team members if they don't know what the heck's going on in your code. So you would want to make sure you explain that. I'm sure like they already talked about this, the instructors, but yeah, that's just where you would say what's going on. And like, you don't have to get crazy with it or anything. Just like there's something weird that maybe you're just trying to explain your thought process, or you even are just curious as to what's going on, you have a little question about something, just say it there, like, why are we adding these? Just stuff like that. Then that's what you would put, and it will get more, and you want more detailed commenting when we get to the topic of functions. And again, yeah, we'll go over those where you make your own functions and can call them within a script. But we're more on that later. But yeah, so that's like most of the stuff on formatting, and just trying to make sure your code looks clean. Like if you're trying to debug and try and understand something, it's going to be really hard to explain to someone that's trying to help you, and it's going to be really hard for you to see it, your team members, all that stuff. So you really do want to take the time. You're going to save a lot of time by taking the initial setup to just make things look clear and clean. And like you guys, everyone should want to do that anyway. Like having clean work is something that's important. Employers are going to want to see that. That's the difference between someone who's messy and someone who's organized and able to explain themselves. So yeah, that's that. And then the other thing is debugging. So the reason why we have the workspace here and why that's so important is because it lets you see what you're telling the computer to do and how it's understanding that. So if I'm telling the computer, hey, add these things that can't be added, and I'm not getting the result that I'm expecting, it's not the computer or MATLAB's fault. It's just a lack of communication. So a way to see what's actually getting conversed and what's being heard is in the workspace. So you just kind of be like, okay, like, for example, if I tried to say D is equal to C before I ever even called C in this problem, like you can see there's no C here yet. But if I just ran this section, it's going to throw an error. It's going to say undefined. That doesn't exist yet. So if I was like, well, why doesn't it? Like I see it right here. You can see that the program never got that instruction yet. So why would it know what the heck we're talking about? So yeah, you can just see that there. And so then we would address that, and then we would see that it works. And you can see here now, say 2 times C. And you'll see that that will end up coming out now. And again, whenever we want to clear things out, we just go to that top section and run that. So yeah, that's that as far as workspace variables. The other beautiful thing about this is if we're running like, we have like an array or a matrix, you can see here, we can see exactly what's in that. If we double click on that, it'll take to our little variable window, and that's what it looks like. So there's no, you're going to want to do that when you're working with matrices and really a lot more complex variables, because it's going to be hard to just kind of, you'll think, oh, this is what's in this variable, but unless that's what is agreed upon in the workspace, then that's not really what's going on. And it's easy to get confused and stuff like that. So that's why the workspace is so valuable. And then another thing is, if you want to just run one line, you don't even want to run the whole section, maybe you have a big section, but you already have the variables in here, but you just want to change something each time, you could say, okay, evaluate selection. So see how I highlighted that, or even double clicked on that line, it's just going to run that line. So for what I mean by that, oops. So if I just wanted to evaluate that line and I'm like, that's not what I'm looking for, then all I would need to do is change this to 5, do it again. And then we got that answer. So again, it will make more sense whenever you're trying to get a certain answer and you're not wanting to run a whole script over and over and over again, or even a whole section, just trying to toggle values and debug. So that's just a helpful tip with that. Again, I know this is a lot, so I'm gonna be providing a little script or an outline of the stuff that I covered, and it's generally in chronological order of how I'm talking about it. Again, that's why CLC, clear all, close all, is so important, because it, you know, you can run that just in here if you wanted. And then as far as debugging goes, when you have no idea what's going on, not sure what's asking, you just type things into Google or even help, like you guys have already seen before, and I know you guys talked about this, but you know, use that, it'll tell you something. And personally, any questions that I would have, help's not going to really do that. Like sometimes if I just forget what it's looking for, the variables it's expecting or something with a function, like I might do that. I might use help if I already kind of know what's going on. But if it's a complex problem, I'm going to Google it. I'm going to say, how do you do this in MATLAB? And that's going to be the fastest route. There's no shame in that. Of course, you want to kind of get a handle of, you know, some of the basic necessities and get familiar with matrices and plotting and things like that, but we can only remember so much stuff. So yeah, so no shame in doing that. That's what the internet's for. And then publishing and submitting projects. So this is something that, again, I know you guys haven't spoken about yet, but .m is the script file. It's what you're handing the machine to execute the code, which is really cool, or it's really useful for the grader to see, because it's like, okay, this was the thought process of why this person did that, but maybe we're trying to get through grading and we could just look at a final report, which is what the PDF is, and not need to go through, you know, trying to fine comb and see what was going on, everything straightforward, 10 out of 10 for the grade. Then that's what the final report's for. And so how we do that, so first I'm going to show you this. So this was my lesson 2. So this is like a finished, see I have a little comment, this is the setup section. The definitions, like we do, again, this might be a little different. Maybe even some stuff in here is wrong, but this was my lesson 2. So again, like I said, you can see I only have semicolons for stuff I don't want to see in the command window, and you're going to see why that's important in a second. But yeah, you can just kind of see, like, this is very readable. This is how you should be, you know, trying to shoot for. Like, obviously everyone's going to have their own preferences. Like maybe someone doesn't like spaces in between, you know, math functions or symbols. Like, that's up to you guys. I don't have always the best consistency, or maybe I have a rule where I leave a space there, but for multiplication I have it next to it. Just little things. The key is to be consistent, because that just makes it more readable. You have a bunch of different exceptions on how you're doing stuff, it can just kind of start looking like a mess. So yeah. So this is an example of where I didn't do that. Yeah. So I'm just going to leave that the way it is. So this was the whole problem for me. If I run this, you can see it all ends up coming out here, which is great. Maybe there's one thing that shouldn't have. I can't remember if it's specifically asked to show all these values. Probably not, so I shouldn't have done that, but that's fine. Or yeah, I guess it did. So that's what it does. And just, like, obviously things are pretty chill right now because it's the start of semester. You guys are still getting the hang of things. But whenever you're running stuff and then you finish, you want to make sure everyone in your group understands what's going on. If they don't, come midterm final time, it's going to be difficult for them to successfully complete the exam, if there is one, which I'm pretty sure there is this semester. At least that's how it's been. So you want to know what's going on. Also, this is like a 2-hour class at night. It's 1 credit hour, so I don't know why people would want to go through this and then not learn anything. So And people always shrug this off because it's a 1 credit hour course. If you ask me, it's one of the more important courses. Everyone will need to do some kind of coding if they're going into engineering. Maybe not civil, but otherwise you're going to be doing it, and you're going to have a leg up on people who can't or just detest it. So I recommend going through, understanding logic and debugging and general problem solving tips, because that's going to translate into good work skills regardless to whether you use MATLAB or not. But yeah, so take the time to make sure your group understands what's going on. Basically, I should be able to ask one person from the group, hey, do you know why you guys did this? They should be able to say. Also lets us know, did you guys copy from someone? I mean, not that, we don't want to assume that's what's going on, but it does happen, and it's just not useful here. But yeah, so make sure you guys know what's going on. Yeah, so there's that. But back to what I was saying as far as running this program, whenever you ask someone to check you out or look over, you should always ask for help when you don't understand something. We'll try to help you work through the problem and everything. But when you ask to be checked out, you shouldn't want to be wasting your time or the graders. Do not say, yes, I'm done, then we run it, and maybe it doesn't run because there's an error, for example, like that, and this happens. So it's going to stop, and it's not going to go to problem 8, 9, or 10. Your code should be able to run without problems when you're checking out. Anytime before that, asking for help, totally different. But when you're checking out, you shouldn't be submitting unless, you're giving up, you're out of time, or, you're just frustrated and not really sure what's going on. Don't want to spend more time on it. Totally understand. That's fine. But yeah, you want to make sure everything is the way it is. No going back of like, oh, I meant to do this. Like, again, same thing in the workplace. When you say you finished a project and you go in front of the owner of the company or your boss or supervisors and you say, yeah, I'm finished. Let me show you what's going on. This is my project. I completed it. And then you're showing people who don't understand the technical aspect of what you're showing them, and then there are mistakes, and then like, how can they trust you? Why are you wasting their time? A bunch of stuff like that. This is just really important things to just practice, because this is kind of what this class is like. Like, here's a problem, solve it as it's asked for. Don't make exceptions, or don't try and like, oh, well, I got close to the answer. Most of these questions are pretty straightforward, so just try to answer them as closely to what's being asked for as possible. But yeah, so like I said, we finished our project, looks clean, runs perfectly. We're like, yeah, I think these are all the right answers. So next what we would do is we'd go over to this little publish button or tool. And so we'd go there and we would hit publish. But before we would hit publish, what that's for is it's going to generate a report. It's going to ask the machine to run each line and print that on a PDF. But before, we want to go to edit publishing options. And we want to make sure this window is going to do what we want it to do. So I think default, I don't know why, is it defaults to HTML, which we don't want. We want to do a PDF. And so we would select that. Also, it's kind of hard to see, like, it's kind of a messy thing. But yeah, so we would do that and we would hit publish. Then it'll go ahead and run through all that. So when it does, it's going to create this HTML folder, because that's where the HTML file would be, the PDF, whatever you guys publish, it'll go in this folder. So I'm going to show you guys what that looks like and why that's such a good tool whenever you're going to upload your .m and your PDF file. It's because this is what it ends up looking like. So you will go to the top. It just has a breakdown of what the different sections are. You can even click on it. It's just super cool. So yeah, there's the header, setup section, my problem 1. That's what I was saying. It's really cool to show it like that. Not really sure why that's like that, but Yeah, sometimes the publisher doesn't always translate well, or if there's a problem, it won't know what to do because of running the code. That's why you want to make sure you have no errors in your code, because the publisher won't work correctly. But yeah, so each section is divided like that. You can see it's just showing, I guess it does show the stuff that's commented or that has the semicolon, but it's not working it out, because if I work this out and here, it would be like, see if it'll do this. So yeah. So if I copy that and put it here, you can see that doesn't run because it's semicolon, but that ends up giving us that extra stuff. So you can see there, that's why we wouldn't want to do that, why we'd want to put semicolons, especially for bigger matrices or vectors. But it just shows you problem 2 is equal to that, and that's what problem 2's answer looks like. So you can kind of see it shows that for all of them. Scroll down. Yeah, so problem 5A, problem 6, problem 7, and then it's pretty much done. And the little credit to the software. So yeah, so that's that. And whenever you go onto Canvas, let's see, pull that up real quick. So whenever you go onto Canvas, and you go to submit, you just want to assignments. Just walking through this, I know a lot of you guys obviously have already submitted stuff and everything. But whenever you would go here, you would, submit the assignment. I thought it would show it, but it didn't. You'd submit the assignment, and then that would let you guys work on that and upload your .m and your .pdf, which is what you want to include both those files in and functions that are also .m, they're going to be their separate file. Again, we'll talk about that later. But yeah, for now, like moving forward, the .m and the .pdf should both be uploaded and submitted for lab 2, or sorry, for future labs. So yeah, that's everything. I'm gonna stop screen sharing. But yeah, so if you guys have any questions, feel free to email me or come to office hours. If you haven't filled out the office hour survey of what you guys would want, go ahead and do that. But yeah, I look forward to working with you guys this semester, and good luck.